All right, so we're now going to talk about some trends on the periodic table. I'm never going to ask you to memorize atoms or elements, but I do need you to understand the trends that exist on our periodic table and why those exist. So the first thing that you need to know or remind yourself of is that our horizontal rows are called periods. Remember, we said Harry Potter, horizontal rows are periods. And elements in the same period do not have similar properties. That's very important. They do not have similar properties. So as we move across these periods, these elements are not similar to the ones next to them. However, in our families or groups, there are similar properties in these. We're going to talk a little bit more soon about what these similar properties are, but I kind of want you to just know as we move this way across our periods, we can't say anything about this atom versus this atom or element versus that element. But as we move up and down our columns, we can say some things. So we're going to look at something called atomic radius. An atomic radius is the size of an atom. So it's the size of the entire atom. It's the distance from the nucleus, which is where our protons and neutrons are housed, all the way to the outermost electrons. And remember, I threw a vocab word at you in a previous video. We called these valence electrons. So these outermost electrons are very important. They're called valence electrons, and we're going to talk about them a lot in this unit. So atomic radius does change as you move across the periodic table. As you go down a column, our atomic radius increases or gets bigger. As you move across a period, our atomic radius gets smaller. So I just need you to understand that general trend. As we move down a periodic table, we have a larger atomic radius, and as we move across a period, we get a smaller atomic radius, and you can see that from this picture here. Next, I'm going to talk about electronegativity, and that seems like a scary word, but there's a fairly simple definition. It's just the tendency, and remember another word for tendency is likelihood, the likelihood of an atom to attract more electrons. So that means if we have an atom and we want to see how likely it is to pick up an extra electron, and as we move down a group, our electron affinity decreases. So another way to say that is as we move up a group, like this picture shows, our electron affinity increases. And as you move from left to right, our electron affinity increases also. So this means that an atom right here is less likely to attract more electrons than, let's say, this atom right here, element right here. Ionization energy is the amount of energy that's needed to remove those outer electrons. Remember, we have a special vocab word for this. It is valence electrons. Trust me, you're going to be so tired of hearing me talk about valence electrons. These are so important. So it's the amount of energy that's needed to remove those outer electrons. As we go down a group, as we go down a group, ionization energy decreases. Another way to say that is as we go up a group, ionization energy increases. And as you move across a period, ionization energy also increases. So you should notice there appears to be some sort of correlation between our electron affinity and our ionization energy. Notice that they are moving in the same direction. So as an atom or element has a higher electron affinity, it is going to have a higher ionization energy. You also notice that these two go in opposition of my atomic radius.